So here we are having one option like a C amplifier draw circuit. So previously I have done already connected circuit by just varying the values. But here what we can do is we can connect the discrete components. So it appears like this. So do the connections as per the requirement given here. Why? Because if you do in a different order, it tells wrong connection. Okay. So L1 to L3. So if you observe here in first point instruction, just move your cursor there, mouse pointer. So it tells everything in detail instructions. If you remove mouse pointer, it will close the pop-up. So L1 to L3. So this is one point, like small kids puzzle it is there. So connect 1 to 3 and 4 to 5, L4 to L5. So L4 to L5, L6 to L8 means connect the input coupling capacitor to the RB1 resistor. L6 to L14, so same input coupling capacitor to RB2 resistor. L6 to L24 means connect the input coupling capacitor to the base of the transistor. Next L7 to L13 means connect the RB1 other terminal to VCC. L9 to L15, so L9 to L15 means connect the negative of the other terminal of the AC source to RB2 other terminal. L10 to L13, so connect the collector resistance terminal 1 terminal to VCC. And L11 to L22 means other terminal of the collector resistance to coupling capacitor, output coupling capacitor. Now L15 to L17. So here we are connecting RB2 to emitter resistance other terminal. L16 to L25. So emitter resistance to emitter terminal of the transistor. Now L17 to L19. So here we are connecting the emitter resistance terminal to bypass capacitor 1 terminal. L18 to L16. So emitter bypass capacitor to across emitter resistor. L19 to L21 to the load. Okay. And L20 to L23. So load to the output coupling capacitor. L26 to L11. So to the collector resistor. Collector to the collector terminal of transistor to the collector resistor. L12 to L9. So L26 to L11 we have done. L12 to L9 means this is ground. Okay, 12 is ground. So no symbol is given. L12 to L9 is ground. Now let's check the connections. It is telling right connections. Okay, if you do any mistake, it will tell wrong connections. Then do everything again from starting. So from here we can do the same process as we have continued in the previous experiment. Okay, set the values here. Like source resistance is minimum 100 ohms. You cannot skip any component here. Okay, these connections must be done as per the requirement given only. You can't skip source resistance and directly connect it to input coupling capacitor like that. These are fixed. So collector resistance 2.2 kilo ohms, emitter resistance 1 kilo ohm, load resistance maximum we are maintaining 4 kilo ohm, base RB1 resistance is 33 kilo ohms. RB2 is 8.2 kilo ohms. Input coupling capacitor is 10 microfarads and output coupling capacitor is 1 microfarad. Bypass resistance or capacitance is 10 microfarad and frequency is 50 50 Hz. Now click on add to table, change the frequency, add to table. Yeah, I am moving it very fastly, but move in terms of hundreds or thousand. Okay, initially with hundreds up to 1 kHz. There onwards you can move with 5 kHz, 10 kHz variation like that. So if you don't change the frequency and click on add to table, it will tell change the frequency. See, so it always requires to change frequency, and don't go back to previous frequencies. It will create wrong plots. Okay, plot done. So we can compare the frequency response also. Why? Because in previous plot it has given a plateau type, and here like some slope type response is obtained.